Next is a very important inversion of a slider crank mechanism, that is crank and slotted lever mechanism. Now what actually is this crank and slotted lever mechanism और इसकी आखिर ज़रूरत क्या पड़ी हमको? Now in certain machine tools like in shaper machines, in planer machines, as we know, the cutting tool reciprocates over the workpiece and it cuts the workpiece. So there we need to convert rotary motion to reciprocating motion. Now why rotary motion has to be converted to reciprocating motion? Because in order to have the continuous motion, one link has to be continuously rotating. Okay, so जो input link रहेगी that should be continuously rotating, but the output link should have the reciprocating motion. The tool should have the reciprocating motion, which is actually cutting the workpiece. Okay, so one of the option can be, we can use either slider crank mechanism. Can we use the slider crank mechanism? Yes, but there is one problem. The problem is in slider crank mechanism, जितना time forward stroke में लगेगा, same time will be for backward stroke. Okay, and in all such machine tools, in shaper machines, in planer machines, always the forward stroke is the working stroke. The return stroke is always the idle stroke. Okay, so अगर हमारा सेम टाइम रिटर्न स्ट्रोक में भी लग रहा है, इट इज अल्टीमेटली द वेस्ट ऑफ टाइम, एंड टाइम इन मैन्युफैक्चरिंग इज एक्चुअली द मनी. ओके, यू आर वेस्टिंग द मैन पावर, यू आर वेस्टिंग द इलेक्ट्रिसिटी, all such things will increase your cost. So what we can do is, because the forward stroke is cutting stroke, it has to be at its own speed, but the return stroke is the idle stroke. Return stroke जो है वो idle stroke, so idle stroke है, so we can move the cutting tool fast during return. That means suppose if forward stroke is the cutting stroke, like suppose in this case, if forward stroke is cutting stroke, so that is moving like this. Okay, return stroke can be very fast like this. So okay, so such type of mechanism which we use is known as the quick return motion mechanism. So this crank and slotted lever mechanism is one of such mechanism which is known as the quick return mechanism. The first quick return mechanism which was used in earlier days, the quick return mechanism which was used was the Whitworth quick return mechanism, but due to certain disadvantages that was now obsolete, and we use this crank and slotted lever mechanism. So you can see in this particular mechanism how this crank and slotted lever mechanism works. Okay, so you can see the forward stroke is taking certain time, which is actually the cutting stroke, but the return stroke is very quick. Okay, now the question arises, how can we achieve such mechanism? So as I told you, this crank and slotted lever mechanism is actually one of the inversion of slider crank mechanism. We have studied about slider crank mechanism, and we have studied about inversion. What are inversion? Inversion means when we are fixing different links, of course one link at a time. If we are fixing different links, we will get different inversion. And this particular mechanism we will get when we are fixing the connecting rod of the slider crank mechanism. Okay, so if we are fixing the connecting rod of the slider crank mechanism, we will get two kinds of mechanism. We will get two types of mechanism. First is the oscillating cylinder engine, and second is this crank and slotted lever mechanism. Okay, so you can see with the help of animation, it will be very clear to you that how we are achieving such mechanism with the help of this slider crank mechanism. So understand this thing very carefully. So initially we are having a slider crank mechanism, as you can see here. Here you can see the fixed link, which is a frame, which is in blue color. The crank, which is rotating continuously, is in green color. The connecting rod is in red color, and the slider, which is sliding over the fixed link, is in yellow color. Now what will happen when I am fixing the connecting rod? And of course the blue colored frame will be free now, free to move. Okay, so here you can see if I am fixing the connecting rod, I will get such mechanism, and this mechanism is nothing but the oscillating cylinder engine. This mechanism can be directly used in oscillating cylinder engine. But in order to use this mechanism as a crank and slotted lever mechanism, you need certain more modifications. Now what extra modifications you have to do, I will tell you. So what you can do here in this oscillating cylinder engine mechanism, what we can do here is just understand this thing very carefully. First thing, we will increase the link length of the yellow colored cylinder. Okay, yellow colored cylinder which was actually acting as a slider initially in the slider crank mechanism, which was acting as a slider, uski link length hum increase kar rahe hain, first thing, and we are making a groove in it. Getting this not? Okay, yellow colored link ki humne link length increase ki, and we are making a groove in it. Then you can see one blue colored link which was actually the frame in the slider crank mechanism, uski link length हमने reduce कर ली, and you can see the mechanism you will get like this. Okay, you can easily correlate these two mechanisms. Okay, yellow colored link which was uska ek end, which was the one of the end of this yellow colored link was fixed to the red colored connecting rod. Here you can see one of the end is fixed to the red colored connecting rod. Okay, हमने उसकी लिंक लेंथ को इंक्रीज कर दिया, उसमें ग्रूव बना दिया. ओके, एंड ब्लू कलर्ड की लिंक विच वॉज एक्चुअली द फिक्स्ड लिंक, उसको उसकी लिंक लेंथ को हमने डिक्रीज कर दिया. Getting this or not? Okay, now very important thing here, you can see two types of rotation here. First is the crank which is rotating about one center, and second is the slotted lever, yellow colored slotted lever, which is rotating about, or you can say reciprocating about another center. And whenever two links are connected together and both the links are having different center of rotation, whenever two links are connected together and both links are having different center of rotation, then there has to be the sliding motion. Okay, I will repeat it again, very important thing. जब भी दो links आपस में connected है और दोनों का center of rotation अगर different है, then there has to be a sliding motion between them, और वही यहाँ पर हो रहा है. Okay, the slotted lever, which is a yellow colored slotted lever, is actually reciprocating about different center, and the green colored crank is rotating about a different center, and both of these are connected, as you can see. So there has to be the sliding motion between them. Therefore this blue colored link will actually slide over the yellow colored slotted lever. Okay, and this is nothing but the crank and slotted lever mechanism. इसमें further एक link लगा के if I am putting the cutting tool, this will actually act as crank and slotted lever mechanism. Now I will show you how this crank and slotted lever mechanism acts as the quick return motion mechanism. So you can see this animation. You can see two different extreme position of the crank. Okay, this is one extreme position of the crank. This is, let's suppose the imaginary crank is at this position. This is one extreme position of the crank. Okay, and during forward stroke, okay, just look at this pin, जिस pin से हमने join किया है, just look at the motion of this pin. During the forward stroke, this pin is moving like this, and final position of this pin is at this particular point. Getting this or not? Okay, that means this is covering this much angle during forward stroke. Forward stroke में ये इतना angle cover हो रहा है. Let's suppose this angle is beta. Getting this on? Now what about return stroke? Now I will continue to play this. Okay, so return stroke में कितना angle cover हो रहा है? Just this angle, which is, let's suppose, alpha. Okay, that means, and as you can see from the figure itself, this beta is actually greater than alpha. Okay, therefore जो forward angle है, that forward angle is actually more as compared to the reverse angle. Okay, therefore the time taken during forward stroke is more as compared to that of the reverse stroke, and that's why this particular mechanism acts as the quick return motion mechanism. Getting this or not?